My topic is on technology and communication. Technology and communication are quite broad areas today. In many cases, each of these terms mean different things to different people, depending on both of their life experience and the work that they do. For example, when some people hear the word technology, they think of computers or video equipment, and not the side spectrum that includes all of technology. Likewise, to some, communication may simply refer to the spoken word done face to face. Both technology and communication are an intimate and integral part of modern life. My purpose here is to explain the relationship between these areas, as well as a practical example of how the relationship between technology and communication has evolved. First, since everyone's personal views of these two subjects is different, based on their experience, it would be a good idea to define what these two areas are. Communication is not just talking on the phone or smartphone. Communication is defined as the imparting or interchange of thoughts, opinions, or information by speech, writing, or signs. This, of course, covers a wide range of methods and paths of the application of transmitting thoughts and ideas. Here is an image that lists some of these examples of technologies used in communication. Likewise, technology refers to the methods, systems, and devices which are the result of scientific knowledge being used for practical purposes. Different eras of the history of humans use different forms of technology. Grindstones, arrowheads, and stone hammers would also represent technology, although we would probably label them crude forms of technology in today's world. Technology appears in our modern world through assorted applications of scientific knowledge into society. In fact, this has been the case throughout human history. Undoubtedly, the movement of individuals into small groups in prehistoric times had to involve the development of communication as well as the sharing of hunting technology. In fact, the knowledge of how to apply their primitive technology would have to be transmitted through some form of communication, probably verbal and not written. Now, whether one believes that the Earth is 4.6 billion years old or a shorter period of time from some religious perspective, there is really no fundamental argument that what we call civilization has been around for perhaps a little over 10,000 years. A common determination of the existence of human civilization is the development of cities and town. This would seem to mark the point where humans have moved from hunter-gatherers to the development of agriculture or a more sedentary lifestyle. To have cities and towns where there would be concentrations of human population, it would be necessary to have access to water and access to food. This would involve having drinking water as well as the ability to get rid of human waste. This would involve also having land for productive agriculture or to get food via trade. This is one reason why many of the first major cities were located on river systems. Memphis on the Nile, Babylon on the Tigris Euphrates, Rome on the Tiber, Paris on the Seine, Budapest on the Danube, London on the Thames, etc. Here is a map of the Middle East that shows two of these locations. Even in more modern times in the United States, we would look at New York on the Hudson, Philadelphia on the Delaware, New Orleans on the Mississippi, etc. All of these examples would require the marriage of communication to communally tie populations together and the application of science and technology to accomplish the transfer of water for drinking, removal of human waste, or the process of agriculture. Especially looking at the development of cities in the Middle East, irrigation would have been important, as well as in the development of technology from wooden plows to iron plows to steel plows, for example. In our times, we think about technology and its rapid change as we appear to be more surrounded by technology, especially electronic technology. It's important in how we operate in our lives, both at home and out in the world. For example, we can find other examples of technology in our homes and personal spaces, in industry and business, and in the medical profession. As I have said previously, we sometimes overlook technology, and we think we know it when we see it, but may not have a good definition of what technology is. Of course, technology is the way we apply scientific knowledge for practical purposes. It includes machines like computers, vehicles, agriculture, combines, etc. It is also found in techniques and processes such as producing computer chips. In fact, we have seen the effects of a shortage of computer chips recently on other forms of manufacturing that are technology dependent. This, of course, influences economic activity and employment in a negative way. The assumption, as indicated previously by some, might seem like all technology is only electronic, but that's just mostly modern technology. In fact, the hammer and the wheel are the only two examples of early human technology. There are many more. There are also technologies that seem rather crude that are still used in modern times. My father worked summers, and when he was in junior high school in his uncle's stone quarry, where they quarried broodstone, which was often used in building walkways in front of homes. Then in the 1970s, they still cut the stone by hand using stone chisels. Today they use the diamond saws and some laser-guided instrumentation for fine work. Now let's look at some of these other examples of how technology plays a central role in our day-to-day lives. At night, you probably go to sleep in a bed. The synthetic materials that compose the mattress, as well as the manufactured springs and the box springs, are the end result of manufacturing process that is dependent on technology. The lights that you turn off just before you go to bed, unless you are afraid of the dark, are the result of manufacturing processes that first occurred in the early 1900s. Plus, it's still likely that the electricity was manufactured at a facility dependent on coal, oil, natural gas, or by nuclear means. So both the light bulbs and the electrical systems that power them are also technology. Before you go to bed, hopefully you brush your teeth in the system that brings you water in the sink, likely at your local water company, the bathroom fan, both from the fan manufacturer and the electric company, the toothbrush, and the toilet from your local water treatment company are all dependent on technology. And communications between different aspects of the system are necessary to make the whole thing work. Today, especially, like many millions of people, you probably turn on the computer pretty quickly after getting out of the bed in the morning. In my case, I just leave it on all night and wake up from its dormant state in the morning. A personal computer, whether it's a desktop or laptop, or even a tablet or smartphone, is a rather recent and most advanced pieces of technology that we developed. Many give credit to our work in the space program and the need for miniaturization of components for some of the rapid technological development that led to the personal computer revolution by the 1980s. All of the processes that led to the personal computer, of course, are technology and has had an effect on our ability to communicate as well as being assisted by communication. Of course, it would be extremely difficult to identify every single example of technology that we encounter each day. There are some that are practical: washing machines, tumble dryers, refrigerators, cars, flooring materials, windows, etc. There are also technologies that are important in leisure: televisions, Blu-ray, players, game consoles, smartphones, reclining chairs, toys, etc. A good practical example of the changes that have occurred both in both communications and technology is what is commonly been known as the U.S. Weather Bureau and the National Weather Service in the United States. It was actually initiated by President Grant in 1870 as part of the Signet Corps. It became part of the Department of Agriculture before being moved to the Department of Commerce under the National Oceanic and Atmospheric Administration Agency. It is now commonly known as the National Center for Environmental Prediction. Most national weather services at about the same time. This is because the data that needed to be transmitted and evaluated could not be done until there was a system for the real-time communication of information, and this was the telegraph. The telegraph did not come into widespread use in the United States until just before the Civil War. It was not until after the Civil War that the vast reporting structure could begin to be constructed. Obviously, the data eventually moved from being transmitted via telegraph to phone lines and then dedicated lines. However, it took natural disasters such as the Great Blizzard of 1888 and then the Galveston Hurricane of 1900 to spur the nation to develop a national weather service that provided both weather data and, just as importantly, forecasting conditions that could present hazards to the general population. However, the difficulties still lay in how forecasts and warning could be distributed to the general population, as communications were dreadfully slow for a long period of time. For example, the Great Tri-State Tornado of 1925 that crossed 3 states, Missouri, Illinois, and Indiana, in 7 hours resulted in nearly 700 deaths. This was the worst tornado-related natural disaster in U.S. history. However, the first radio station in the U.S., KDKA, in Pittsburgh, Pennsylvania, did not come onto the air until 1920. There were no radio station networks to broadcast warning on, and the first large numbers of television stations until after 1950. Therefore, there was no large-scale communications network available to warn the public easily and quickly until at least the 1930s and then the 1950s. The 1950s were also significant in that the first generation of weather radars were built and deployed by the mid-1950s. These were crude by today's standards. They were not in color and could only identify areas of light, moderate, and heavy precipitation. They also had a limited range, but they were an enhancement over what had been available, as likely thunderstorms could be identified. Eventually, by the late 1970s, these were replaced by color weather radar that had 6 shades of color identification and gave more detail. However, the radar beam was merely bouncing off of the droplets of precipitation, which told us where they were, but nothing more. By the late 1980s, a new evolution of radar was beginning to be deployed, Doppler radar, which could tell forecasters not only where the precipitation and intensity of precipitation, but how it was moving in the atmosphere. Areas of rotation could be identified, allowing the identification of tornadoes that have been developed or about to develop, These were advancements in technology that could lead to more protection of the public. However, the problem was also the speed at which a warning could be distributed to the public. For a long period of time from the 1950s through the 1960s, 1970s, and into the early 1980s, the Weather Service had relied on the weather wire. This was a technology and service that was extremely slow by today's standards. It was subscribed to state by state. You could not have access to entire country data and forecast. So in Michigan, a TV station and radio station will subscribe to the Michigan data, so they may not have access to storm information. This information was at about 74 baud, which is about at the speed of a slow typist. Fortunately, as technology improved by the late 1980s, and the introduction of the satellite transmission of data, and then over the internet, the availability and breadth of data and forecasts improved significantly. This meant that the types of data changed. For example, the upper portions of this diagram show the upward progression of the number of tornadoes observed. Some have looked at this as cause and effect between global warming and severe weather. Although global warming may have had some impact, it is likely that the introduction of weather radar in the 1950s and Doppler radar in the late 1970s caused more tornadoes to be observed. This can be seen in the lower part of the figure that the number of particular pathway for information made the great internet interaction that allows a society to operate. Advances in technology and communications may have had a positive impact on the application of scientific knowledge, but perhaps not society. The references used were 1925 tornado, Weather Forecast Office, Packagua, Kentucky. Website included weather.gov, Phoenix, James L.R. in 2021, the NWS Gateway, A History in Communications Technology, Evolution, NOAA, National Weather Service, again at weather.gov/HISGate. Hamilton C. and Kroll T. 2018, Communicating for Results, A Guide for Business in the Professions, 11th edition of Cengage Learning in Boston, Massachusetts. Waldeck, J. Kearney, P. and Plax T. 2013, Business and Professional Communication in a Digital Age, Wadsworth, Boston, Massachusetts. Wood, David, 2021, November 29th, Examples of Technology in Our Everyday World, study.com/academy/lessons and examples of technology in our everyday world. That was my topic. Weather and technology.